Okay, more integration for Year 2 students and a simple standard one here, integrating using partial fractions. So, we have show that 11 over 3 marks, show that 11 over 2x minus 3, x plus 4 can be written in the form of a over 2x minus 3 plus b over x plus 4. So, let's do the maths. This is part A. So let's let's change the thickness of the pen. That's better. Part A, and yeah, let's have a go. So we got 11 over 2x minus 3 x plus 4. X plus 4. And we should extend that line a bit. And that will give us, of course, a over 2x minus 3. And plus b over x plus 4 plus b over x plus 4. And we have that as a common denominator, of course. 2x minus 3, x plus 4. So we have 2x minus 3 and x plus 4 as our LCM. And of course, a goes into that, the other. So it's a multiplied by x plus 4 and plus b by what is the other, which is 2x minus 3. 2x minus 3. And we can equate our denominators, and that will just leave us, if we do that, if we equate our denominators, our LCMs, we're going to be left with a x plus 4 plus b 2x minus 3 is equal to 11. So we got a brackets x plus 4 plus b brackets 2x minus 3, and that will all equal 11. Now we substitute values. Well, that gives us 2x minus 3 equals 0. So 2x, if I write here 2x minus 3 equals 0, which implies that x is equal to 3 over 2. So I can substitute that in when x is equal to 3 over 2. So when x equals 3 over 2, I've got, well, let's have a look. 3 over 2 plus 4 equals 11. I got 11 is equal to 3 over 2, a, plus 4a. Yep. So 3 over 2 plus 4, so I've got a is, 11 is equal to a, and 3 over 2 plus 4. And of course, that will give me a is equal to 2. 11 over 2a is equal to 11, so that will give me a is equal to 2. And when x is equal to minus 4, so I've got x plus 4 equals 0, so I've got x plus 4 equals 0, so x is equal to minus 4, and when x is equal to minus 4, we've got b and minus 11, b minus 11 is equal to 11, and therefore b is equal to minus 1. You can check that after doing your algebraic manipulation. So I've got a is equal to 2, b is equal to minus 1, which means therefore 11 over 2x minus 3, 2x minus 3, x plus 4, x plus 4 is equal to 2 over 2x minus 3, 2 over 2x minus 3, minus 1 over x plus 4. And that's part A for 3 marks. Part B, it says, hence find the integral of 11 over 2x minus 3x plus 4 dx, writing your answer as a single logarithm. So, the sensible course of action to deal with that for 4 marks, this one, in part B, is to, first of all, think about using the reverse chain rule. Yeah, again, wow. So let's have a look at this one. If we look at using the reverse chain rule, again, we're using f prime of x over the function of x dx, which is equal to, again, the log of the modulus function of f of x, yeah, plus c. And again, that's our reverse chain rule. We've used that a lot in this further integration for A level. Reverse chain rule again, and that will give us, well, if we look at part B, 11, so let's integrate 11 over 2x minus 3 and x plus 4, which is dx, I've got to write dx, which is equal to, now the integral of 2 over 2x minus 3 minus 1 over x plus 4, and let's put all that in brackets, and we've got to multiply by dx. Now, this gives us the log of 2x minus 3. That gives us the log, natural logs of the modulus function of 2x minus 3 minus the natural log of x plus 4 and plus c. And using the laws of logarithms, okay, so I just using laws of logs, yes, laws of logs, which is log of a minus log of b is the log of a over b, which gives us a natural log of 2x minus 3, 2x minus 3 over x plus 4. And there you have it for 4 marks. And just to reiterate, that's the log of a minus log of b is equal to the log of a over b. And there you go. Now, 9 minutes, we have time for one more where, here's an integration where, using partial fractions, where the denominator is of a lesser power than the numerator. The numerator power is greater than the denominator. So, what do? We don't jump ship. We have to think about what it is we need to do. And the sensible course of action is to look at the question. You can do this multiple ways, but one sensible way is to say, well, this is x cubed plus 2 divided by x plus 1. So there's a polynomial division there, and it's sensible to use polynomial And here we go. And some of you say, well, I've forgotten that, but don't panic. You can do it quite easily just by focusing on the title, which is, it says, x cubed plus 2 divided by x plus 1. So let's do that. My pen is not working, and this is all real time. So, right, so we've got, for 4 marks, we've got x cubed plus 2, and this is the integral of x cubed plus 2 divided by x plus 1, which means, if I do it here, this is x cubed plus 0x squared plus 0x and then plus 1, and all divided by x plus 1. And you have to ask yourself, what do I have to multiply x plus 1 by in order to get x cubed? Well, surely you're going to multiply by x squared. Well, do that. That will give you x cubed plus x squared. And subtract, and there you will, your x cubes have gone, and you have 0x squared minus x squared, which gives you minus x squared, and you bring down the next number, which is 0x. Again, you have to ask yourself, what do you have to multiply x by in order to get minus x squared? Well, surely that's going to be minus x. So minus x times x, that gives you minus x squared. Remember, you're subtracting, so directed numbers, that you're going to get rid of your x squared. And of course, minus x times 1 gives you minus x. Again, subtract, your x squared terms have gone. So you have 0x minus minus x, which gives you plus x, and plus 1. Well, that's what you have. That's great, because what do you have to multiply x plus 1 by in order to get x plus 1? Well, that's it. You multiply by 1. So that gives you x plus 1. And you subtract, and you get 0. Which means that you are going to integrate what you found as your result, which is x squared minus x plus 1, and of course add c to it. So there's a method that you could use in order to solve these particular problems. So how do you go about doing that? So now, whoops, let's move down the page. And conscious of the time, we could just write here. So you're going to integrate now x squared minus x plus 1. And of course, this becomes 1/3 x cubed minus a half x squared and plus x plus natural log of x plus 1 plus c. And that's it for 4 marks.